right, welcome back to Online with an Architect. My name's Josh Odgers. I'm your host for today. Got a very special guest. In fact, all my guests have been very special so far, but I don't say that lightly. But a person I've known for many, many years. Welcome to the show, Vaughn Stewart.
Hey, Josh. So glad to be here.
Yeah, it's great to see you. And I remember vividly our meeting in Sunnyvale, and when you were in Melbourne, we went out for lunch and drinks and all sorts of things over the years. So it's I haven't seen you in person for a few years, but good to catch up on the podcast.
Yeah, I really appreciate being on, and it is good to catch up. Obviously, we've had a long history together, and our careers have taken us through different vendors and onto new journeys. And so, congratulations now with the podcast. Obviously, I've stepped away from social media a little bit, maybe, I don't know, 5 or 6 years ago. Yeah, I think we were talking about a little bit about this before we got onto this call here, but yeah, happy to be on and happy to share with everybody kind of what's going on in the world of vast data and actually what I think is the next really big wave of IT and infrastructure requirements around AI. And so let's how do you want to jump into this?
Yeah, well, I was thinking we were talking obviously before recording a little bit about our social media histories and blogging and,
Yep.
Being that person disseminating information, things like that. So do you want to share with us some of those thoughts? Because I've certainly learned a lot from you over the years on what to do. And I've certainly made some mistakes on what not to do myself. So pleased to hear, your experiences.
Yeah, okay. Yeah, so I had a pretty good run in social media. Actually, let me maybe introduce myself to your audience for those who don't know me, and then I'll touch on the social media piece. So, Vaughn Stewart, I am the Vice President of Systems Engineering at Vast Data. I've been there about 6 months-ish. I'm not quite tracking there, but spent the prior 9.5 years at Pure Storage, and prior to that, spent 13 years at NetApp. And was really fortunate in my career and during that time frame I joined NetApp at 900 employees and, got to, watch the vendor that really won, the evolution and the creation of the NAS market. They kind of then introduced, multi-protocol. And for those of you, if you were ever in the VMware space, I got to have a front row seat actually driving their strategies around what we called virtualization and at first and called cloud. So I'm responsible for NFS data stores and data deduplication on storage arrays and vendor plugins inside of vSphere back in the day. So, that's my background at NetApp. And while I was at NetApp, I did an M&A research and found this little company called Pure Storage at 43 employees and got there rated around 100 employees and kind of very similar. Kind of had watched the vendor that I think really won the initial all-flash array, kind of market. There was a lot of startups in that space and Pure got it right. They bet on commercial grade flash and how do you raise the resiliency of that. And when I was there, I was the architect who built their evergreen consumption model and had 2 really good runs. And interestingly enough, and we'll come back to this, if you would have asked me 2 years ago or 3 years ago or 4, what's next? I would have told you it's absolutely positively not storage. Not again. I've been there. I've done that. And now you're going to ask me why I'm at Vast Data, and we'll get to that in time. But during that time period, I started blogging and started having a large social media presence. And so when I left NetApp, I was responsible for a significant portion of their blog traffic. And at Pure, did the same thing in the early days. And, it's interesting to kind of watch because, we would get online and, passionate, educated technologists, and I'm including yourself in this, and a lot of our cohorts, Chad Sakich is a very good friend of mine and Chad and, he was in that space along with many, many others. And, we would want to educate the market on what our companies were doing to enhance, what their business initiatives were around cloud computing or data storage, et cetera. And, it just started to become toxic and it just started to become much more about the fights and the clashes than actually the collaboration and the exchange of ideas and the debating of merit. And for me, it just got to a point where it even crept internally inside of Pure, and I just said, I'm good. I've made my mark. I've shared a lot. It's time to walk away. And I've been asked by, leadership when I was still at Pure and leadership now at Vast to start it back up. So in January of 2024, I will be relaunching my blog, and I've got a lot to talk about. And some of those topics we will probably touch base on right now, right here.
Perfect. Breaking news then on Online with an Architect. Fantastic. Yeah. No, I certainly agree with you. Like, the twit pissers, I think they're called affectionately. I've certainly been involved in my fair share over the years. And, if we look back, sometimes it's, it might be entertaining or things like that. But the question is how much value is, doing those things to effectively our end customer, who you and I are both, champions for customers. And our passion is really for customer outcomes. So, if those Twitter debates result in great business outcomes for customers, I would do them every day. I wouldn't get off Twitter, right? But the question is, do they actually help that much? And,
Right.
probably occasionally there's information that is incorrect that can be corrected and customers can get some value out of that. But I'd say the vast majority of that is just negativity, which possibly is just distracting from the focus on the customer.
I think a lot of people enjoy the entertainment of vendors kind of debating, and maybe some people picked out nuggets of value between it. But I think what really didn't get any light exposed on it was how much you, myself, say Chad Sakich, who I mentioned earlier, Ivan, who used to be at HPE back in those time frames, how much we and others collaborated on the back end to drive support for applications or new standards or frameworks within the partner ecosystem, be it Microsoft or VMware, et cetera. A good example is like when VMware rolled out VAAI, which was the VMware API for array integration. That wasn't a VMware-based initiative. It was the culmination of a number of vendors all pulling at VMware into different directions about making points of integration. And instead, on the back end, we got together and we collaborated and said what would be the biggest bang for the buck for all of us, aggregated that together, and then presented that kind of as a unified front. And I don't know how often that happens anymore nowadays. The adoption of cloud computing, and again, it kind of started under a different moniker known as virtualization. That really drew in all the infrastructure vendors and even the software application vendors into a centralized community about a new paradigm and a new architecture that was going to become prevalent. And here we are today, right? Many generations after that in terms of IT generations, which are about every 3 years, but not human generations.
Yeah, exactly. Yeah, slightly longer human generations, hopefully. So,
yeah.
so with social media, putting you on the spot here, I should have prepped you with this. What would your 3 tips be for someone who's trying to get into social media? They want to be an evangelist and follow in your footsteps, I guess. What sort of things would you do, and what would you not do? Again, I guess get involved in twit pisses is probably top of the list, but
yeah, just anecdotally, I never listen back to when I've been interviewed somewhere. It's just I can hear all the ahs and ums in my speech pattern, and it drives me up the wall. But I did stumble on one once, and it was right after I'd kind of walked away from social media. And it was an interview. It was hosted by Amy. Why am I having a brain fart on Amy's last name? Amy Lewis. Sorry, Amy. I did not mean to brain fart there. I'm just getting old, and it's the geriatric in me. But and I kind of talked about this a little bit, and so and then kind of looking to relaunch my blog and get back into active in the social media spaces. I think there's some real simple guidelines, which is don't trash your competition. Talk about what you do. Nobody wants to hear you go throw the hammer at the competitor, and heaven forbid, you're probably not as accurate about what the competitive technology is as you think you are. Right? You might be spot on some points, but you can't be on everything. So, talk about what you do well. Talk about what your company, product, offering, etc., is doing to advance the goals of whoever your target market is, whether it's B2B or whether you got a consumer product. So that's one. 2, integrity. Integrity matters. So there's times where the real value about being online is lifting the kimono a little bit, right? Explaining how things work. Hey, this thing that we do in our product is strong over here, and these are the reasons why. Maybe not so strong over there, right? Like you want to make sure that the customer is going to invest time and more importantly, their capital in acquiring your goods and services, that they're on the path to have outstanding success, right? It's so much more work when you got to dig a customer out of a ditch because they've applied your technology in the wrong use case than it is to, just go off and have great success. And then I think third, you said three things. So I shared two. So I think the third what might be, you know what? Don't make sure you're communicating your voice. The whole reason for social media is so that you can add additional perspective. And I want to be clear on this. I've watched a lot of people that get online and they go repeat what the information that's on their vendor's product webpage, the vendor they work for. Nobody cares. It's already out there. It's on the product webpage. Your job, if you're going to be in social media, is to enhance the conversation, to enrich the amount of data and information that you're sharing. It's to, if you're technology centric like we are, right? It's to go a little bit further than maybe what the marketing team wants to say at a high level, because you've got a technical audience who needs a little bit more detail so they can make a better, more informed decision. And so, focus on yourself, not on your competition. Make sure that you're being accretive or additive to the conversation in general. And somewhere in there, again, the old age kicked in here, and I can't remember what the third thing I said was.
So the third one is add some value, show your own perspective. So I agree completely. I think if you have people parroting a marketing message from a company, then there's not a lot of value in that. If you want to retweet or you want to repost or whatever they're called these days on all the different platforms, that's fine. That's completely fine. But if you're literally just copy pasting and presenting it as new information when it's actually copy paste, I think there's no value in that. Better off supporting the person who's created the content and reposting and supporting that content for sure. Because I can go to a product webpage like you say and learn the marketing. I want to know Vaughn Stewart's opinion, because Vaughn has a different perspective and experience than the marketing team or the product team or even the engineers. Like, you're a solutions person. You're not just focusing on one area. So I think that's what people want to hear, is someone who has experience with the products, has experience with competitive products, and can share a value prop without going too negative as well.
Yeah, it's funny because I won't say this person's name, but I have a person that used to work for me who's still, representing a company and does his online social media kind of engagements. And, the person's got great charisma and everything that you'd want. And last time I ran into him, I just said, like, hey man, like, I'm glad that you're doing well. I'm glad that you're seeing everything's great. Like, but you're not saying anything. And I think I hurt this person's feelings, and that wasn't my intent. And so, you know who you are if you're watching this, but that was really kind of going back to the points that we were making earlier, like share the perspective of what you're learning from your engineering team, share the perspective of what you're hearing from your systems engineering team when they're out in the field, share what you're hearing from customers, whether you're meeting them in person, they're speaking on your behalf at a conference, or you've got them in an executive briefing center. Like, that's what I'm talking about in terms of, enhance or enrich the conversation by collecting all these other data points and then sharing them online.
Yeah, indeed. I think integrity is the other key point that you mentioned is, make sure you're factual, do your absolute best to be factual at all times. And, as much as I might have changed a few things I've done in the past on social media, I don't regret being factual. So I think even if the facts are not popular, if they're well researched and proven, I think it's completely fine to point out factual information. But obviously it's difficult to be an expert in multiple products. So I certainly couldn't put out product comparisons on 20 different products because I'm only an expert in a very small number. But yeah, I think putting out facts is okay. But again, if you focus on your own product, then correcting misinformation is kind of okay. You go too much further and it can be unconstructive.
You know who loves when you share accurate information about how your product works and functions? customers.
Mm.
Who doesn't? Competitors. And you're never going to get everybody happy. So maybe that's tip 4. Have some thicker skin, because if you're doing what you're doing well, and particularly if you've got a disruptive product offering,
Mm.
and I think both you and I have been at disruptive vendors, the barbs are going to come because you're challenging someone's paradigm.
Mm. Yeah, absolutely. Change is something that I don't think as humans we tolerate very well, and yeah, unfortunately, people push back quite hard and sometimes aggressively on change. But like you say, we've got to have thick skin in roles like ours, and yeah, focus on the positive. Yeah, actually, I was telling you off air a story, and I'll gloss over it a little bit. But there was a funny comment sent to me the other day about that people should read my old articles, and I thought that's actually a really good point. I would really encourage people to read some of my old articles, and then review that vendor's current documentation, and have a think whether I was being factual or not, because the new vendor articles mirror pretty much exactly what I wrote years ago. So, to be accused of certain things is not very pleasant, but we have thick skin, so we don't let that sort of nonsense bother us. But again, if you're factual and you say things with integrity, the truth comes out in the end anyway.
Haters gotta hate.
That's exactly right. So that's a lot on social media, but maybe you can give us a bit of a breakdown on what vast data is. And I'll confess, I've done no research on vast data. I know very little, actually. I've seen a few things pop up in my feed, but I know very little. So this is actually a really good learning opportunity for me. So selfishly, I'm very happy you're here, but I'm sure lots of people can benefit from learning about vast data and what you guys do.
Yeah. So yeah, let's get into something that's actually living up to all the chatter that we had before or prior to. So VAST is a data platform for the AI era, and we provide enterprise as well as cloud service providers a global data infrastructure offering that unifies storage, database, and what I'd call virtualized compute engine services into a scalable system that was built from the ground up for AI. And, I said a lot there. And so we should probably, for your audience, again, who are architects, tease that apart so they understand that the constructs of what I'm sharing here. But before I do, we've had tremendous success to date, right? We are the storage platform under the leading hyperscale GPU clouds. Those are, some of you may be familiar with them, some of you may not, but Core 42, Core Weave, and Lambda, as well as, we're used in all types of industries, from, public reference customers include G Research, Pixar, Zoom, the Allen Institute, Verizon, NASA, the National Institute of Health, the United States Department of Defense, Lawrence Livermore National Labs, University of Utah, the Texas Advanced Computing Center, da 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 da.
Names there.
And so, yeah, so I rip off a lot of names, but let's just kind of pause and talk about the market that we're addressing and the challenges we're addressing, and then we'll talk a little bit about our product offering. And so, in the storage realm, there's a lot of products that are designed for a very specific type of workload, right? You make block storage arrays, and these are usually for systems of record, right? Transactional type of systems, databases, etc. They make unstructured systems like NAS that serve SMB to Windows clients and NFS to Linux clients, to deal with unstructured data. You've got S3, large volume, massively scalable systems that by and large are more for archive, not that they can't be for production uses, but at least historically they're for archive. You've got hyper-converged infrastructure platforms that they're not quite storage, but they are the amalgamation of compute, storage, and the demarcation for networking to support virtual machines and containerized workloads. And we're none of that. We are a massively parallel data platform that gives you the performance of high performance computing. So we're talking about, per client reads and writes in the tens or hundreds of gigabytes a second, to an enterprise storage in terms of the availability, resiliency, feature set around data services and multi-protocol access and simplicity to operate. And we're moving into an area that is not traditionally storage in terms of database, data engines, events and triggers. And so in some ways, kind of like what HCI did to, converge a number of infrastructure components together, we're doing the same thing around data. I talked about this recently on a CUBE interview from supercomputing. If you look at what's happened in the storage industry over the last 10 to 15 year window, the storage vendors got all focused on flash media. The startup started 15 years ago. The incumbents, started to retrofit their systems a little bit after that. But it was all around, how do I shift from disk drives to flash, and with that, not only do I make a more performant system, one that's also more ecologically friendly to the environment, but how do I tear down bad behaviors and things that we've built around spinning drives? And I'll come back to that a little bit more in a moment. But so meanwhile, while the storage vendors were on this pace, you saw all this innovation happen that was storage adjacent, if you will. HCI is one, right? A lot of virtualized footprints left storage arrays and went over to HCI platforms. But you also saw the emergence of analytic platforms where, prior to, the speeds we have today with storage and networking that all were about, bring the compute to the compute, however you want to frame it, was the co-location of compute and storage together. And that started as, analytics processing, and then became, data lakes, and then, they evolve into data lake houses. And, these aren't typically ran on storage arrays, right? They're made out of compute nodes. You also had, the emergence of stream processing, right? So, I've got all these event triggers and logs that are going on in my environment. And so how do I aggregate them together? How do I, take action based on what's in a stream, right? How do I standardize the content of the stream for more faster processing? And again, so if you're looking at a world like Kafka engines, for example, they're storage adjacent. They store data, they process data. They're part of a data pipeline, as well as you've had this massive explosion around, database technologies. I mean, 15 years ago, you had Oracle, SQL, and some other, SQL-based, offerings like Sybase, et cetera. And, today you've got all of this massive explosion around databases, and they all function interchangeably with unstructured data around the enrichment of data, the processing of data, the data pipelines that are going into, what we used to call analytics, now which really, are AI and accelerated computing with GPUs and IPUs and TPUs, et cetera. We're at the time frame of a significant shift, I think, in terms of how we look at infrastructures, and probably one that's larger than what got kicked off in 2006 with virtualization and evolved into cloud computing. And part of the reason I'm at VAST is that I get to experience it firsthand from the data platform perspective.
Yeah, it's certainly a new market. It's certainly evolving very, very quickly as well.
Yeah, I mean, if you look at, so let's talk about this a little bit. I said earlier in the beginning of the podcast, right? If you would ask me, I had friends go to VAST in the very early days, and just hey, wish you luck. I'm not kind of looking for something beyond storage for what was next, and that was really the byproduct of when I was at NetApp. We got to evolve the product into lots of different use cases and functions, and it was always very intellectually challenging, right? You were always learning, evolving, and moving forward. And by contrast, I got to Pure, which is a great company, and we did some amazing things in terms of the products we brought to market. But by and large, it's a SAN company, and unfortunately, when you're in the storage space and you're dealing with SAN, it's about price per gig, IAPS per rack unit, and what are your resiliency and business continuity capabilities. It's there's not a lot of focus on what the application is. There's not a lot of integration to the application up stack. I mean, it's very much a commodity conversation versus unstructured data. Is very much around what are you trying to accomplish in your business? How are you aggregating, ingesting, and processing data? And that always evolves because the tool sets around it are constantly in flux. So coming to VAST, when I started getting recruited to come to VAST, and that started with Jeff Denworth, and then I got introduced to Brendan Halleck, who's our CEO, and both of those are two of our three founders. The focus on AI was the first thing that caught my attention. I'm like, okay, I want to be challenged to go and learn something new, to go and understand the problems that's inherent in this evolution of the infrastructure and market. The second reason I'm here was, I was getting recruited in March of 2022. I'm sitting down with Brendan Halleck, and he's shared with me that the next protocol that the VAST platform would support was SQL. And I thought, oh my God, you're adding SQL to a box that does NFS and SMB and S3. You're going to bring structured to unstructured data. Like, this is amazing. And then he said, well, then we're also working on a global namespace. And I'm like, hold the phone, right? Like pick one. You can't have both. This is just audacious. And look, we've shipped both of those products. And so focus on AI, the boldness of trying to bring something new to market, and then the leadership. Those are the three reasons I'm here. And the things I've been able to experience in the 6 or 7 months I've been here has just been mind-blowing, because we're dealing with customers and challenges that are at this massive scale. You won't find VAST data in a commercial market. You probably won't even find VAST data at the low end of the enterprise space. We're probably Fortune 500, maybe even Fortune 250 kind of centric. And then beyond that, federal and university research facilities is really where we're at. Our target is, how do we help customers address vast, there's a parody. How do we help customers deal with a significant volume of data and all the challenges that go around that? And so, yeah, it's been a great experience and a great learning curve. And so let me dive into this so that your audience kind of understands. It was just a little bit over a year ago, GPT-3, gets launched, and you see this massive explosion around the demand for AI through, every enterprise. But preceding that, the GPU usage, it was, very predominant inside of high performance computing, right? The research facilities around the globe. And the storage that's predominant in HPC is called parallel file systems. And so if you've got an enterprise storage background, you probably more than likely have little to no experience with a parallel file system. But a parallel file system is one that's designed, it's very boutique. It's designed solely around performance. You have to install clients onto your Linux systems, and you build a cluster of Linux systems. It could be hundreds or thousands of them to make a grid, if you will. And you need to process data as fast as possible. Well, that's the performance level that we bring in VAST, but we do so over NFS. We do so in an enterprise set of capabilities like I talked about. And probably one of the most important ones is around availability and resiliency. So, I don't know HPC, I've had to learn a little bit about HPC as I've gotten here, but what I got to learn was the number one goal for most research centers is to do more research. And if your high performance, both compute fabric and storage infrastructure has to go down because the storage is unavailable, you can't do research. And what's evolved over the last decade is you'd build these big Linux grids, and they'd have this client, this parallel file system client that ties into the kernel. And I should pause here. When I say parallel file systems, I'm talking about platforms like Lustre or GPFS or BGFS. Well, when you update the Linux software, and this isn't me saying that, I've been told this by multiple customers and prospects, right? I've had customers tell me they couldn't get the storage. They've had storage taken offline because the client clashes with the new software updates and they can't get storage for weeks at a time, not days, weeks. So all research comes to a stop. And so what we've seen in the university space is used to build these Linux grids and they wouldn't get touched for years because they're fragile. The parallel file system was the fragile component of it. And now you've got the cybersecurity team inside the university saying, oh, something in your stack just, got identified as having a vulnerability. The patch has been put out and you need to apply the patch within the quarter. And literally you had computational grids coming offline because of conflicts with the parallel file system. And so that level of fragility doesn't exist with us because we're doing this over NFS. It could be NFS over Ethernet, it can be NFS over RDMA, it could be NFS over InfiniBand, but we're doing it with a standard client. We've also contributed and got some support in getting it adopted by the Linux community, what we call a multipath NFS client. So, traditionally with NFS, you used to get about 2 gigabit a second per link. In NFS v3, you could have one link for communication. And then you had an enhancement called NConnect, which allowed you to establish multiple TCP sessions up to 16 per target. And so you could go from 2 gigabytes a second of transmission to about 6 or 7. And that's where you see most storage vendors kind of peak out today. And we added multipathing, which was to say, hey, what if this NFS server was multi-homed? I want you to send IO concurrently over all of these links to all of these adapters. And with that and our architecture, which we haven't even gotten into, go look at our SuperPod certification, right? Per DGX client performance exceeds 60 gigabytes a second reads. That's the highest tier that NVIDIA tests for, and we blew way past that. But, so we're talking like almost an order of magnitude higher performance required for AI than what you get out of a traditional enterprise NFS or storage platform today.
Actually, there's 2 points I wanted to highlight here because you've touched on 2 things that are very important. Obviously, for these use cases, performance is critical, right? So performance, very, very important. You've talked about how you've scaled that out efficiently with the multipathing. So that's quite important. The one to me that's even more important, though, and I talk a lot about this to customers and on blogs and things like that, is the aspect of the day 2 operations and business continuity. So you talked about how, with traditional systems, there's downtime associated. There's a lot of interoperability issues. You could take a grid offline due to security vulnerability patching or just the complexity involved in that process. So I think people don't always consider how valuable a system that's got good day 2 operations is in the real world. So even if your performance wasn't necessarily as high as your competitor, if your day 2 means that you're very rarely, if ever, having to do downtime for maintenance, you have a massive advantage. And to your point about these research facilities, if you can keep their research going 24/7, 365, that's an amazing business outcome for them. And on top of that, if you can do that with better performance, then it's compounding that benefit. You're not having downtime and you're performing at a higher level. So the amount of research you can do per day, is significantly increasing. So yeah, I like the focus there on that day 2 operations piece because I don't think companies in general focus on that enough. And I would say almost all vendors don't focus on day 2 enough as a general rule.
It's funny. I communicate with my team, which are the systems engineers, North American systems engineers, particularly the western half of the United States, is my team. But I try to communicate to them like, your job is not to answer questions. Your job is to understand what the customer is trying to accomplish, then to educate them on how we can help them meet that goal. And so, kind of going back to the long-winded HPC story, what's important to research facilities is to attract researchers. And you attract researchers by being able to do more research. It's a real simple equation. And so, I've started to have this talk track around, performances how fast your platform can read or write, but B, how available is that platform, right? Like you can go, a gigawatt, gigawatt, whatever they said in Back to the Future. You can go, some astronomical number performance, but if you can only get to that, 60% of the time or whatever it might be, then what's the average in terms of the actual work you can do? Let's pivot though. Let's get out of HPC because most of your audience doesn't have an HPC perspective. Let's talk a little bit about AI in the enterprise and kind of what we're seeing and then what that plays for. And then let's dive a little bit into our architecture and tell people how we deliver it, right? I think there's a why and then there's a how aspect. So, when I joined VAST, what I heard was, oh, well, Vaughn, you're in the Bay Area. There's AI everywhere, but there's no AI in Minneapolis. There's no AI in Dallas. There's no AI in Phoenix or San Diego. It's only in Silicon Valley. And, what I learned quickly was by going out and meeting our customers and our prospects and our partners and our teams was that if you ask if companies are investing in AI, you get about a 40% positive hit on that. But if you actually just change that question briefly and say, are you investing in GPUs? It's 100% hit rate. And so what I find is when you ask around AI, it usually like aligns more to like initiatives, let's say around new technologies like large language models or multimodal large language models, where companies want to bring in this technology and they want to, enhance or add some new capabilities to their platform or their product offering. And so that becomes classified as an AI initiative. But for a lot of these other vendors, could be genomic sequencing, it could be chip simulation, it could be a digital twin, it could be protein folding. A lot of these platforms, they don't call it AI, they call it accelerated computing. And so, what I find is if you just say, are you investing in GPUs or GPU centric, accelerated computing platforms, the enterprise is 100% on board. And so let me give you an example, right? I can't give customer names here, but so working with the chip manufacturer, they do a lot of chip design, right? A lot of EDA type of work. And they have a chip simulation software that they use that runs on CPUs historically. And the EDA data sits on enterprise NAS platform historically. And they're talking to us and they're like, hey, we bought a SuperPod. That's an NVIDIA platform. There's only, it's a full architecture from, GPU, computing, fabric, storage, and the software. And by the way, there's only 4 storage vendors that are certified for SuperPod. It's the 3 parallel file systems I shared with you earlier, and the associated hardware vendors that run those. So, Lustre is what DDN runs with, and GPFS is what IBM runs with, and BGFS is what the NetApp E-Series platform is certified with. And then there's us, the VAST Data with NFS. And, we exceed the highest performance tiers. There's a good, better, best inside of that space. But they basically said, look, we bought a SuperPod and we've got a parallel file system and we want to see what you could do here. And the question is like, they're like, well, we're a little worried because the parallel file system is evenly balanced in its read and write performance. It can read as fast as it can write. And the VAST is more read centric versus write. And so, we're concerned about that. And your gut reaction is you want to start to understand and like go like this FUD. Let's start talking about my product. And instead it's like, let's back up. Like, what's the problem that you have right now? And they're like, well, our chip simulation software went from CPU to GPU and it can now run 20 times faster. And that has this impact of reducing multiple months out of a development cycle for chips. And you're like, okay, cool. Big business value. What's the problem? The problem is our GPUs are only about 20% utilized. We're not seeing that 20x gain.
Yeah, you bottleneck.
And you dig into why, and you're like, oh, because the data sits on the old enterprise array, and they copy it out as fast as the enterprise array can read, but in these AI-centric terms, it's very slow. In enterprise terms, it's fast, but they're reading data out and they're filling up this parallel file system, processing it very quickly, and then even slower, writing it back to the old legacy platform. And they're like, we want our infrastructure to be AI capable or GPU capable. And this is what we're seeing everywhere, which is you can look at AI and do a little silo if you want and say, I'm not going to touch the rest of my infrastructure, but you'll never get the efficiency and you'll never get the benefit of applying your current IP and letting it be processed by GPUs because you're just stuck with bottlenecks. And so our pitch was, look, we can be the storage in the superpod and you can keep your model of shuffling data back and forth, no problem. Or we could be the storage for your EDA data and you can just bring the GPUs to where the data already resides. And, so you do a proof of concept for how fast can you process the AI workloads, and you do a proof of concept for how strong are you at supporting, billions of files because it's EDA. And, 6 months later, they've bought off on this model, and the first iteration of this is going, to be installed here, and we're going to prove it out for them, and then over what we hope will be the course of the next couple of years is we'll keep turning that infrastructure over and modernizing it so that they can leverage GPUs on demand, right? Not having to move data around and wait for the data to get there, just have the data available.
So, I mean, architecturally, at a conceptual layer, you've done something I think is very important to do, and a lot of the time we miss it, which is you've stopped unnecessary data movement, or you've stopped unnecessary operations in general from having to be performed. So straight away, if we're moving data from A to B, both the source and the destination need to be capable of doing it and have the processing power to perform the task. And then at the same time, source and destination are probably performing other functions. So the functions that are performing at the front end are being impacted by that back end operation. So simply consolidating that workload onto something that can handle both, eliminating the back and forth, is a huge efficiency gain. It's eliminating the operation, which is even better than making it fast. And then it's allowing most of the operation, regardless of how performant the device is, to happen at the front end instead of wasting it at the back end, which is not, back end is very rarely delivering business value. The front end is where the value is given.
Yeah, this is probably a good time to segue to, why VAS and what about our architecture actually allows this capability.
And there's actually one other point I want to touch on, because again, it's something very important. Many years ago, you and I actually collaborated behind the scenes on a blog, and the blog was talking about peak performance versus real world performance. And you reviewed this blog for me, so I hope I gave you credit on the blog. But basically, I used the Bugatti Veyron as an example. All right, it was the fastest car in the world at the time. It could do 407 kilometers an hour, I think it was. So 250 miles an hour, whatever that converts to. And yeah, it's the fastest in a straight line. It's the fastest top speed. Fantastic. But how sustainable is that in the real world? And there was two constraints. One of them was its fuel tank, and one of them was its tires. So its fuel would run out in 12 minutes at that speed. So it wasn't sustainable for a period of time. You had to be on one of those big, oval tracks, and it would run out of fuel very, very quickly. Luckily, though, it ran out of fuel before the tires exploded from the heat, because that was the second constraint, which was the tires would only last 15 minutes at that speed due to heat and the expansion and the G-force and the pressure. So then you compare the Bugatti Veyron to a very typical car that any of us can afford, and it's going to be probably more reliable and day-to-day give you the exact same outcome at 1/100th of the price. So that blog was called Peak Performance versus Real World. And I think to your point, if you compare a product, and let's say product A has 10 million IOPS of capability read and 10 million write, and then another one has 2 million read and 5 million write. I'm just making up numbers here. If your requirement is only 1 million, it doesn't matter that one of them is 10 times faster. right? It also doesn't matter if you eliminate the I/O having to occur in the first place. So this movement we talked about, if we eliminate that movement of data, then that requirement for back-end performance is lower, and you can buy a lower performance device by just simply being intelligent, which was the VAAI you talked about earlier. But you've got a key point here, I can tell. And we've both got our pens. We're pointing with pens, so it must be good.
So it's funny, right? I don't remember if I did this publicly, if I did it privately. But years ago, I have you ever looked at what Red Bull F1 Racing, where they've taken the cars and they've put them in non-racing environments to see how they perform? So they drop them in the desert and they run them on sand. Yeah. They drop them on ice and they see how they run, right? And I'm like, this is really analogous to like what we do. Like you could be super fast, but the environment doesn't allow you to capitalize on what that car can deliver because the car wasn't designed for that. And moving data, if your company's looking at an AI initiative right now and looking at it as a silo, I get it, but you're going to store multiple copies of your data. You're going to end up taking more rack space and power, and then you'll never get to the efficiency that you want because of the data shuffling. And so going back to that conversation we had where they were like, well, hey, this other vendor writes at a more equal read and write level. It's like, by and large, almost absolute, but by and large, AI is about taking a large volume of data, processing it, and giving a refined output. It's not the other way around. So it is read-centric, and it's random read-centric in terms of that space. The reason this customer was worried about reads and writes is because they had to load that data all the time. So they were like, I don't know if you can write data fast enough as it comes off of the legacy NAS. And it's like, we write data faster than the legacy NAS can read and send us the data, right? So, but again, they're trying to solve a time issue because what they would not do is replace the legacy infrastructure with parallel file system because of the rigidity and the client, impacts of having to maintain it that we kind of talked about earlier when we were talking about HPC. And so, if I just pause here, right? February 2006 was when VMware released vSphere 3. That was the moment where adoption for VMware took off. And every enterprise wanted the value of consolidating, at that time, tier 2 and tier 3 applications, right? It wasn't about performance. It was all about, I've got a data center full of underutilized hardware assets. And I remember that, right? So you had the leadership had FOMO. We have to adopt this technology. We've got to move forward. And you talk with infrastructure people, and this conversation probably lasted about 4 years, from like 06 to 10. The infrastructure folks had no idea what to do, what to purchase, or what to buy. The default behavior for most, go buy a SAN. And then what did you run into? You ran into a clustered file system that couldn't scale. You had SCSI locking and other scale issues. The number of runs you could make or volumes from a SAN, right? Didn't work. And then when you ran into performance issues, customers were doing things like concatenating volumes together and putting the clustered file system on top. And we were at NetApp and we're like, there's a faster way to do this. Get rid of the clustered file system. Just do, at that time, the best NFS platform in the world, the NetApp NFS platform. And then because we did direct storage to the hypervisor, then the next thing we did was, let's start doing API calls directly at the virtual machine or virtual disk level down to the storage level. So we could do snapshots and clones and start to provide data services directly to the VMware admin. And then, right, these, large SAN and NAS platforms had all this redundant data. So, you roll out data reduction and you change the economics of the environment. And then the backup environment changes, right? There was no Veeam or Cohesity or Rubrik in 2000. Well, Veeam maybe in 2006, they saw it coming, but right, like you had to get granular on your level of backup. Same thing on networking. Software-defined networking came out because you wanted to be able to tweak the networking all the way down to the virtual machine, not just the endpoint. From that, right, your monitoring tools got granular. And I think I share this with you is because I think we're in that storm right now, the very beginning of this, is your infrastructure AI capable? And how do you want to adopt AI or accelerated computing? Because I don't believe it's its own thing. I don't believe you say, well, that's my silo for a large language model, and we're going to do some training and inference on it. I think AI and GPUs or IPUs, TPUs, whatever the platform is, I think it's pervasive, and I think it's going to be behind every type of analytical system that's within a customer's infrastructure. And so I don't think it's if this is coming, and I don't think it's can I go afford to build another silo. I think you have to literally sit there and say, all right, what's my journey to adopt faster computing and having the benefits of my business of this acceleration, and what changes do I have to make in my infrastructure? And that set of questions and the whole I don't know what to do from an infrastructure perspective, I think that's very relevant today, because we meet customers every day who basically say, I don't know what I need. The AI initiative is coming from the board or the executive team down. It's got a lot of visibility. We've got big plans, and you can't fault me if I bought the fastest storage on the planet to support it, because I don't know what it needs. And that's kind of where we come in and say, well, let's talk about what you're actually trying to accomplish, right? And going back to the example we had a minute ago about moving data, there's much more, right? About enriching data and what are your sources of data and how is it coming in? And do you need to pre-process the data? And, it's such a yada yada. But we've talked a lot and never even gotten to VAST yet.
Yeah. I think conceptually, though, we've covered a lot of really very important topics. And like you say, it was server virtualization, then it was HCI, then it was NetApp with NFS, then it was the flash storage arrays being more commercially attractive, all this kind of stuff. It's the same concepts. And obviously we're talking architecture on this podcast. This is why I always highlight to people, understand the concept first. Don't go down and design at the physical layer and talk to me about your storage or whatever if you don't understand what the business problem is and conceptually what you're trying to achieve, so that you can translate that into a technical solution and then measure it back to the business. So conceptual, logical, physical is what everyone should be, designing to. So anytime we have a problem, and you've pretty much followed this process in this conversation, by the way, you've talked a lot conceptually about what the problems are, and then you've translated that down the logical and physical layers. So very important for us to do that.
Look, the techies watching this are going to be upset. They're like, you didn't go deep enough. And I always try to tell people, like, if I do my job well, I'm gonna leave the technical people disappointed but wanting more, because I think you have to focus on why. I can't say it enough. Before we go and debate two different implementations of some type of technologies that have relatively similar promises of what the results are, again, what are we trying to solve for? Going back to your conversation, right? I got to move fast. Well, what do you mean move fast? Is it one person in a car flying down a freeway, or does it mean I have to move my house because I bought a new house and I sold the old one. I got to get all the stuff moved out of the house faster, right? And in that case, I probably need a moving truck, which doesn't go fast, but in terms of volume, is the fastest way to solve that problem.
I think you made a joke years ago about the fastest way to move 10 terabytes or some amount of data was a tape in the mail. And I was like, that's probably true, actually, in a lot of cases, rather than a slow WAN link and replication, all this sort of stuff. So, yeah, I mean, a moving truck.
I think I said something like it's like a FedEx truck. Like the bandwidth is great, but the latency sucks.
Yeah, exactly. I think that was it. And your example about the Formula One car, I remember your presentation, actually. You did a bit of a roadshow, and you presented in, I think it was the Melbourne VMware user group or the V Forum or one of those events back in the day, and you put that slide up. And I remember I took a photo of it and tweeted that out because it was perfect. It was a great analogy for, you might have the fastest widget, but if the fastest widget is constrained by everything else around it, it's irrelevant. It doesn't make any sense. So what you're getting to, I think, here with VAST is you're creating a standard platform for everything that matters that works together. So for all those workloads and data sets. And to me, that's kind of what NetApp was trying to do, because they would do the intelligent snapshots, and then they'll do the intelligent replication. So you eliminate your agent-based backups. And so you're eliminating all this data movement that's unnecessary while achieving equal or better outcomes for the customer. So I feel like, yeah, like you say, it's just coming full circle.
Well, let's dive into this a little bit so that my corporate handlers don't want to slap me around. But so VAST was formed in 2016, and they created an architecture which we call Disaggregated and Shared Everything, or DASE, DASE. And the contrast of this architecture is that every storage system that your audience has been exposed to today is basically a shared nothing architecture. And what that means is that the networking interfaces, the computational capabilities, and the storage are all one stack. And if it's dual controller architecture, then you got two of them. If it's a quad-based architecture, like an EMC, type of array, but it's still like the controller can only address the storage that's assigned to it, and can only send that communication out over the interface that is physically connected to it. And even if you look at HCIs, where HCI platforms where you still have this shared nothing architecture, and then it's doing a lot of east-west traffic, so that it can add resiliency and availability to it. That east-west traffic degrades the system's performance over time, because you're trying to make sure that you have coherency in the data that's coming in and out of the system, but you're having to do all this east-west traffic on the back end. And so the DASE architecture is one that has like three core elements to it. The first is that all the protocol access points are containers, and these containers run on traditional, x86 platforms, and you can order them through us, and they're fulfilled by our contract manufacturers. We're not in the hardware game, right? We're software only, but we also have HPE OEMs our platform. It's known as GreenLake for file. Dell is an investor, so we've got customers that use Dell servers for the containers. But that's your point of access at the top layer. On the back end layer, we make basically a JBOF storage enclosure that we call a DBox. It's got a high availability architecture inside of the tin, but that is then comprised of storage class memory, which acts as a write buffer, and QLC flash, which is your persistent tier. Connecting the containers, which run on what we call C boxes, to the back end persistent tier of D boxes, is a low latency, high performance fabric that could be either Ethernet with connected via RDMA, or InfiniBand. Again, both RDMA based protocols, so NVMe over Fabric or InfiniBand. And why this is different than a shared nothing architecture is that every front end container can address every storage class memory and every flash device on the back end. And so when you pair this up with clients, like I talk about the multipathing NFS client or multipath SMB, it allows you to break the paradigm. Pick a traditional NAS vendor, right? All my IO goes through one interface, through one controller, to one disk, shelf or tray or whatever on the back end. And by contrast, we can spread all the IO, even for a single file, across all of the front end servers, comes over to the back end fabric, and can hit all of the flash on the back end. And so actually, as our systems get larger, they get more performant. This architecture today supports, as I mentioned earlier, SMB, NFS, S3. Every piece of unstructured data for us goes into our table, so it can be queryable by S3. By SQL. Sorry, not S3, but can be queryable by SQL, which provides a lot of capabilities that you can't get when you're trying to understand what's the data on your platform, but you're bound by POSIX tools, right? Like, hey, if I've got a multi-petabyte environment and I say, show me all the files that are owned by Josh Odgers that are larger than a gig, but he hasn't touched them in over 6 months, I have to go walk that file system. And depending on how large that file system is, even if it's all flash, it could take hours or days. And for us, it's like, select all files owned by Josh larger than a gigabyte, not touching 6 months, and the response is immediate. It's because we've got a database engine inside of the platform, and this is just the beginning of the capabilities. On top of this, we're using QLC flashes, which all the hyperscalers use, and all the modern all-flash vendors, right? It's very low cost. We have to put a lot of design in the architecture so that we add endurance to the flash. Part of how we add endurance to the flash is the write buffers, right? So we are in a very resilient platform. We're writing all of our writes to storage class memory. This is buying us time to buffer those writes into stripes. Also, while we apply data reduction to that, so we can lay the stripes out in a nice and kind manner to the QLC on the back end. We support data deduplication, which looks for similar blocks globally across the system. We support data compression, which takes an individual file and reduces the redundant blocks inside of the file and reduces the amount of space it takes out of flash. And then we've got a proprietary form of data reduction called similarity, which basically says, find me two objects or two files that are similar but not identical, and collapse down everything that is identical between them and only store just the deltas between them as two completely different versions of the same file. And so, we get best-in-class data reduction, within this space. And so what you net out with is I have this architecture that can scale non-disruptively, performance with the C boxes, capacity with the D boxes. All of my my performance is as high as HPC. My price per gig is like what you'd consider like an archive tier, like a tier 2 storage, right? I'm very affordable. And those two capabilities come together to be actually ideal for AI, because in the AI world, the more data that you can process, the more precise your results are. And once you've trained a model, say you've trained a model and you're done today, it's not like the training stops. You publish that model and more data keeps coming in your system. And then you need to train and refine and update the model. And that doesn't mean you just get to look at the new data. You actually have to parse all of the old data. So constructs that we've had in the data center, which is like, this is the hot data, and then I'm going to move it to cold data to a lower cost, cheaper, but slower storage platform. And then I'm going to move it to an even slower platform like Archive. That stuff goes out the window with AI, because I have to perpetually look at the model, and the model perpetually grows. So I have to support the performance needs and the economic needs. And there's no one in the industry besides VAST that can do that on their data platform.
And that tiering is a hard problem to solve. Certainly, working at Nutanix and a lot of storage experience, and of course you have as well, that is a very, very difficult problem to solve. Like, there's so many tiering capabilities out in the market for enterprise storage, and none of them work amazingly the moment you exceed a certain threshold. Like, there's that magical cliff that you just fall off with tiering. And, I remember many times in the early Nutanix days, a customer's working set would exceed the flash tier. And then what's the solution, right? I remember quite a few projects because it was SATA at the back end. Right? And basically,
Little's law comes in and kicks your ass, right? Like, so Little's law basically says it's not about what your fastest IO is; it's what's your outlier IO. And so, like, if you get in the analytics space and you're dealing with like Splunk or Elastic, and they've all moved to these S3 architectures for scale, but they front end them with cache, and it's like, look, you could have 99% of your data coming from that cache. The query that you ran or the report that you're generating doesn't complete until the long tail IO comes out of whatever the slowest tier is. And that's just the reality. And so, you see a lot of customers invest in low cost archives and then surround them with very expensive caches to try to counterbalance it. It's, I kind of said earlier in the podcast, we build off of like band-aids and fixes from the past. We just keep like compiling on top of them, versus kind of taking a step back and saying, is there a better, more modern way to do this? And the vast DASE architecture again, I think it's a better model, particularly for the type of data and the volume of data that we need to deal with today within AI. And the rate at which data is generating is not slowing down, right? It's accelerating. And so if you're not going to do it with VAST, then you're going to end up building silos and go back through that example or some permutation of the example I shared with you earlier.
And silos are always, like, from a, again, architecture perspective, if we have a silo, there's going to be that team that manages that silo are going to be happy. But everyone around them are going to be miserable because then they've got to work out all the different associated integrations, how to maintain and support it and scale it and all this sort of stuff. So the more silos we have in an organization, the cost becomes exponential. The complexity is exponential. The risk, therefore, is going up. So I always try to say to customers, look, we don't need to have the best of breed for every single workload. We need to have a platform that can support as many workloads as possible and deliver equal or above your requirement and be scalable. So you don't have to be the fastest day one. You don't even have to be the fastest by the end of life. You've just got to meet your threshold of your requirements and hopefully exceed it by a little bit so you got some buffer. But this is what I like about what you're saying is you're trying to make that day two simple where you're not having a silo for everything. Because, again, silos just add complexity and cost.
Yeah, so let me give you another example, because I think the big value for those who are infrastructure centric today in their jobs is to always expand what your knowledge is, right? For me, I was at storage vendors and I'd always go kind of up stack, right? It was before virtualization, it was, the Microsoft apps. After virtualization, for me, it was a bunch of analytics platforms. So in the vast data platform, all data lands in what we call the data store, which means all data is stored and is accessible through any protocol, whether S3, queryable by SQL commands, NFS, SMB. But what's really starts to get interesting is now you take the database capabilities that we have, which, and I don't know how much of the audience knows this, but when you start to get into the data space, right? Storage stores data. Data systems actually put data to work, right? So you've got things like relational databases, online, transactional processing, like systems of record, Oracle or SQL or name your database, right? And data is stored in rows, right? It's like, it's Josh Rogers and he bought this, widget from our store and they're going to ship it to this address for him. And those systems are great because they're fast at entering entries, across the schema. Well, OLTP databases are written in that format because they were written for rotational media. So how do I write data that works with the underlying infrastructure? But conversely, when you actually want to query data, those architectures are really bad because if I just want to say, show me everybody who made a purchase in the last 30 days of the same widget Josh bought, I have to read all the data, all the rows. I can't just, look at it from a columnar view. So companies, extract, translate, and load that data into a data warehouse, which now stores everything in a columnar space, which means on a per transaction, I have a horrible time trying to insert the data, but now I can go look at, the segments of the data. Show me everybody in the Sydney area who bought this product. Show me everybody who bought this type of product. Show me how many times Josh Rogers bought a product from us. Historically, you can't have a transactional database support an analytic use. And whether the analytic use is called a data warehouse or a data lake or a data lake house, and those are all kind of permutations that expand beyond this. I don't want to upset anybody in the big data space, but stay with me here. What we can do with the vast database is we can support fast transactions because everything's written into our system like it's written from a row as we write it down to storage class memory. But then when we migrate it to QLC, it's actually wrote in a columnar format. And so it allows you to do real-time transactions followed by real-time analytics. And that in the data space is kind of like the holy grail, something that is not possible with, your traditional or even your modern databases. And so again, going back to the basic premise of like data movement and time and infrastructure tools and, services you got to pay for, we're giving you a transactional database and a data warehouse function off of one copy of your data. And then here's where it gets really cool. So are you familiar with Apache Arrow?
I'm certainly not an expert, so
Apache,
talk to me like I'm a kindergarten person.
yeah. Well, I'm not an expert either, so I'm going to give it into layman's terms. So Apache Arrow provides connectors for database platforms like the vast database, and modern data query engines like Spark and Trino. And so here's what's really interesting. With Apache Arrow, we can actually take the granularity of data and actually break the data boundaries of formatting and give greater results on queries. I probably said that in a very bungled way, so let me break it down for you, right? So open source file formats, one that's very, very common for putting data and putting into like a data warehouse or a data lake, is like a Parquet file format, right? It's a columnar format. You could almost think of it like a mini database file, right? Like almost like a little access data, what access database is to SQL, Parquet, so, and Parquet files have this variable, which is if I make them large, I get compression, I get to reduce the cost of storage. But when I want to search for data, I got to read more data and then process out, all the misses to get to the hit. I can make them small and reduce the processing time, but then I lose all my, compression because I'm bound within that file format. And so it's going to cost me more in terms of infrastructure costs, et cetera. If you put, say, Spark or Trino, and you put it on a sub-millisecond all-flash array, like one you might find from any of the legacy storage vendors, ones that come back in 400 microseconds or whatever in terms of latency, and you query data on that, it comes back at a certain time and you go, wow, this was fast. It's much faster than if it was on disk. When you put that data on us and you put it into our database and use the Apache Arrow connector for your data query engine, again, Spark or Trino, what we're able to do is actually retrieve the specific data that's being queried for versus the whole Parquet file. And on average, that's about 1/4000th of the amount of data required. And so while our latency is more like a all-flash NAS latency, like 2 milliseconds, 3 milliseconds, and an all-flash array's got like a half a millisecond, we're actually 20 times faster on retrieving the data, because when the query hits us, we give them back only the bytes of data that they're looking for versus the whole Parquet file, which then has to get loaded into the query engine, disassembled, all the trash thrown out, and then here's the nugget you were looking for. So again, getting back to how do I do more with my data? How do I do more in my infrastructure? How do I reduce time? It's about building a better engine, a better platform for supporting not just the storing of your data and the performance and economics of it. How do I bring in your other tool sets, like your query engines, to process this data? And then how do I accelerate those, not just with Flash, because it's faster than disk drives, but actually breaking the boundaries of why we used to write all these paradigms for, columnar databases and row-based databases, and just saying, I can be much smarter because I'm using this media in a way other storage vendors have put to use at this time.
So, I love this point, actually. I say this to customers all the time, is when you are testing a product, you need to understand what you're trying to achieve. So if I was to test your product, which is, I think you said 2 millisecond latency on average, let's say 2 to 3, whatever, and I tested it against Pure Storage. Cool. Pure Storage, 0.4 of a millisecond. Great. So if I measure you on that one criteria out of context, you would look bad and Pure would look really good. But if I measure the business outcome, which is I want this data processed, you would come out on top. Not necessarily against Pure, just in general, right? You've got a great outcome because you're delivering the value in a different way. You're not just serving data fast. You're getting the right piece of data and serving it slightly slower, but the total time to process the task is less. And I think you said 20 times less or 10 times less. So, a significant amount less because you're doing things in an intelligent way. And I've said this to customers all the time for many, many years, is don't focus on one thing. Don't focus on the old benchmarking tools and your peak IOPS and all this kind of nonsense. Focus on let's test what you're trying to achieve with a product or a solution and measure the outcome. And forget about the steps in the middle. Because if I'm the slowest latency at retrieving the data, but my total time is condensed due to that intelligent operation, then I don't really care my latency is 2 milliseconds. It's irrelevant because my total task time is so small that the latency is, not a factor.
Yeah, I think for your audience, if you're going to focus solely on hardware benchmarks, and you're looking at hardware results out of context, you're probably doing your organization a disservice. And just take a step back. Over the last 15 years, what's had more growth? Software platforms or hardware platforms, right? Like, there's that's obviously a rhetorical question. There's no comparison here. So, taking the time to understand just a little bit more about what the IO looks like, higher in the stack, can save you a lot of pain and save your company from, making a poor purchase decision.
No, absolutely. I think that's really cool to frame something like that is, hey, our latency will look worse, but here's why, right? It's a valuable piece of information for someone to understand. And you're taking longer because of you've already processed in the back end, so you're only delivering that small piece of data. No point sending, terabytes of data at crazy speeds if you don't need most of that data. Right? You're just moving data for no reason. So avoiding the movement of data is probably the best innovation you can do at a storage layer.
Yeah, look, I would be surprised if much of your audience hasn't already or will be engaged in some type of GPU-centric, effort. They're either working on it now, or they're going to be working on it sometime in the next 6 months of the first 6 months of 2024. Again, Josh, we deal with. I got a POC going on with a customer right now. They have to read at a terabyte a second. And somebody goes, "What the hell needs to be read at a terabyte a second?" I'm like, "Well, that's okay, because we have another POC going on where the customer needs to read at 16 terabytes a second." And you're like, "What do they need to read?" And I'm like, "Well, don't worry about it. It's all about your security." So, like nation state security. But like the to think that this is edge in terms of use case, not meaning like the edge, like collecting data, but if you think the adoption of GPUs is not everywhere, you just need to get out of your silo, because I assure you, every enterprise, every national or research facility, every the universities that are focused on research, you can't get away from one that's not doing some form of accelerated computing. And honestly, for me, kind of going back to why am I vast? It's been overwhelming in terms of the volume of information and the net new products that companies are building and want to bring to market and capabilities. It's just it's probably a good way to kind of maybe wind this down, because I think we've gone long, but it's been very, very rewarding. And look, we're at VAST. There's so much more than what I shared. Our data space, which is our global namespace, and then our data engine, which is going to GA here in the beginning of 2024, which is all about stream processing and actually having functions and events tied to that data, so you can process it as it's coming in. We're not building this stuff blind. We're listening to the customers that have massive volumes of data, and they're telling us, "Here's how you make my life easier. Here's how you let me get to complete a process faster." And this is an interesting triangulation, because we're dealing with infrastructure people, storage people, and we're dealing with data platform people and data scientists, and usually the two don't meet, right? Storage folks are array centric, and data people tend to be server centric with software on top. And so, look, we've got some work to do around education and market awareness, but
every disruptive
it's a lot of fun,
right? So bringing teams together and collapsing is kind of what the VMware folk used to try and do, is bring people together, collapse, compute and storage. So I think you're just doing the same down the track in a different space. But I agree with you. I think most companies are looking in this space, and if they're not actively looking right now, they will be very shortly. Otherwise, they're going to lose a competitive advantage and be behind the game. So yeah, it's an interesting space. And maybe a bit of a request for you is, once you've done one of these proof of concepts, and obviously anonymized, if it has to be, I'd love to get you back on and run us through a case study of a business outcome. Of course, anonymized, but go through the detail, go through what was trying to be achieved, how it was achieved, and the methods involved. I think that would be quite well received by the audience.
Yeah, I'm happy to. I'm not the best. Oops, sorry, I clicked something on the interface here. Because we know each other and we have a very casual conversation, right? I probably skipped over some things about VAST and just some other data points for your customers. But we recently just had a fundraising round, our E series. We raised $118 million. Mm-hmm. We've got a $9.1 billion evaluation as a startup, as a sub 700 employee startup. To put that in perspective, that at the time of the evaluation, Pure Storage's market share was 9.9. So one tenth of the employees, and nearly the same valuation in terms of the market.
And newer,
we're doing something right.
So I think it's it's huge growth, and both of us have experience at startups, and then those are some impressive numbers for sure.
Yeah, and then I mentioned earlier that we are the storage platform for a number of hyperscaler GPU clouds. I mentioned Core 42 and CoreWeave and Lambda. All three of those clouds started with a parallel file system vendor, and they've all gone and looked for alternatives because, what's the key when you're a service provider? SLAs. One of those SLAs is not just performance; it's availability. So, we seem to have cracked the code. We're not going to be your household name. We're not going to be in all of the accounts. So if you're more commercial centric and you've watched this podcast, I appreciate your time. But we're right now. It's I think our average customer size is 10 petabytes. We've got a customer that's nearing an exabyte under a single namespace. We've got multiple, multi-hundred petabyte customers. So our game is scale, and you may not be there today. You will be in the future. I still recall the first NetApp system that I had when I was a customer. It held 80 gigabytes of storage, about 60 gigabytes usable. And that was in, I don't know, just taking a swag here, 2, 4, 6, 9 rack units. And now 60 gigabytes sits on a drive the size of your thumbnail. So, if your company's not in the tens of petabytes today, you will be soon.
It won't be long till those are very normal numbers in the low end of the enterprise space, I would say. So, it's good that you're trailblazing and setting us up for success in the future.
Yeah, man.
Very cool.
What else can we talk about?
Damn, I think that was really good. I think we've hit the nail on the head with the timing as well. But certainly I think, talking in the future on maybe a part 2 about the global namespace and the value in that, I think would be very valuable. I think that's an underrated capability. Global namespace is not easy to achieve. And then, run through a case study. I think that's something we're going to focus on more on the podcast, is doing case studies of real-world deployments of technology and mapping them back to business outcomes. So if we can do that with you, that'll be a fun episode, and you can bring along a friend if you like.
Yeah, let's do that, because I think we can bring some visuals and some metrics. I rambled through a lot of stuff here and kind of, a soft level of details, if you will. But we can harden it up so that there's a lot of folks in our space that are like, show me the data. So I think we can do that.
Yeah, data's good. And I suspect you have a vast amount of it. So
see that? See what you did there?
Yeah, very cool. Well, Vaughn, it was a pleasure catching up, and I look forward to catching up in person at some point and doing a part 2. This was good fun. Thank you.
Yeah, sounds great, Josh. Take care, buddy.
Great. Cheers.